Welcome to this video lecture. In this lecture, we are going to learn how to evaluate integrals using Parseval's identity pertaining to Fourier Sine Transform. So to begin with, let us see the definition of Fourier Sine Transform, which is defined as Fs for a function f of x is a root of 2 by pi 0 to infinity f of x sine sx dx, and the final answer will be in terms of s, that is denoted as Fs of s. The Parseval's identity for Fourier Sine Transform is given as integral 0 to infinity Fs of s the whole square ds is integral 0 to infinity f of x the whole square dx. Now let us see how to evaluate some complicated integrals using this Parseval's identity. Take the first one. Evaluate the integral 0 to infinity x square divided by x square plus a square the whole square dx using Parseval's identity. And to begin with, let us analyze this integration, because in previous class we would have studied how to evaluate such integrals using Parseval's identity of Fourier cosine transform. There you would have observed on the numerator there would have been only a constant 1 or some number, but here the difference is on the numerator we have a variable. So whenever we have a variable on the numerator, we may have to use Fourier Sine Transform Parseval's identity. Let us see what is the necessity for that, because when we particularly take Fourier Sine Transform of e power minus ax, the answer here you will have s by. But in Fourier Cosine Transform, in this place we would have got a. So that is why whenever we have constant on the top, we have to use Fourier Cosine Transform. And when we see a variable on the numerator, we have to use Fourier Sine Transforms. This is a basic thing which you have to remember. Now let us see how to use Parseval's identity to evaluate this integration. For that, we are choosing the function e power minus ax, because here you have a squared. So that is why here we are choosing e power minus ax. And for this e power minus ax, let us find Fourier Sine Transform first. This is the definition of Fourier Sine Transform. Root of 2 by pi 0 to infinity f of x. So now in the place of f of x, we are particularly substituting e power minus ax into sine sx dx, which is given by root of 2 by pi. And look at this integration. We have to use this integration formula to evaluate this. So we have to compare with this integration formula. Here in the place of a, here you have a, and in the place of b, here you have s. So comparing with this integration formula, the final answer of this integral is b by. So here in the place of b, here you have s. So s by a squared plus b squared. So a squared plus s squared. So look at this. We have got the answer of the Fourier Sine Transform in terms of s. So this we call as f of s. Of course, the suffix denote it is Fourier Sine Transform answer. Now let us proceed to find that integration. So here we have made use of the input, which is f of x, as e power minus ax, and the output, that is the Fourier Sine Transform answer, is this root of 2 by pi s by a squared plus s squared. So make use of these two functions in the Parseval's identity. So this is the Parseval's identity of Fourier Sine Transform. Let us substitute the values of fs of s and the value of f of x in this Parseval's identity. See here, in the place of f of s square, this is the answer of f of s. So we are squaring and we are writing here. And in the place of f of x square, here this is f of x. So that we square and write. So e power minus ax, when I square, I get e power minus 2ax. So here we have given the explanation for that. E power minus ax square is e power minus ax into e power minus ax, which is e power minus 2ax. And when you observe this, it's a very simple integration which we can immediately integrate and find the answer. So e power minus 2ax, when we integrate, we have e power minus 2ax divided by minus 2a. And we need to apply the limit from 0 to infinity. So upper limit, in the place of x we have to put infinity, minus lower limit, in the place of x we have to put 0. So upper limit minus lower limit, and make use of the values of exponentials, that is e power minus infinity we know is 0, e power 0 is 1. So substitute e power minus infinity is 0 and e power 0 is 1. So the final answer is 1 by 2a. This is of course the answer of this right side integral. Now look at the left side integral. Here you have like this. But when you look at the question, see here the question is in terms of x, the variable x. But here we are getting the answer, but in terms of the variable s. So just we have to do a simple thing, that is changing the name of the variable. See, like this we have got. Here simply we are changing the name of the variable s to x. So all the s terms will become x terms. And taking this 2 by pi to the right side, you have 1 by 2a into pi by 2, which is pi by 4a. And this is the final answer of this integration. So this is how we have to evaluate an integral having variable on the top using Parseval's identity of Fourier Sine Transform. Now let us do another problem. Evaluate the integral 0 to infinity t square by t square plus 25 the whole square dt using Parseval's identity. So in such integration, again look at the numerator. You have to observe the integral first of all, which Parseval's identity you have to use, either Fourier cosine transform or Fourier sine transform. That is the first decision we have to make. So look at the numerator. Here you have variable. So whenever we have variable on the top, see, is it not similar to this integration? Yeah, whenever we have variable on the top, we have to use Fourier sine transform Parseval's identity. So let us write the Parseval's identity of Fourier sine transform. So this is the Parseval's identity, and particularly the function f of x which we have to select is going to be, see, look at this term, accordingly we have to select. See, for this term we selected the function as e power minus ax. See here, we selected the function e power minus ax in order to get this integration. But here you have 25. So in the place of a squared, actually we have 25 here. So what must be that a must be 5. So the function which we have to select is e power minus 5x. So this is how you have to analyze and you have to select the suitable function in order to evaluate this integral. So let us select f of x as e power minus 5x. And once you have selected this input, let us find the output. Output means the Fourier sine transform. So evaluate Fourier sine transform for this function, which is going to be this definition, root of 2 by pi 0 to infinity f of x. See, what is, this is the definition. What is f of x here? E power minus 5x into sine sx dx, which is going to be root of 2 by pi. Now again, this integration, you have to make use of this formula for this integral, e power minus ax into sine. So whenever you have exponential and sine, you have to make use of this formula. Comparing these two, you have in the place of a here you have 5. So a is going to be 5. And in the place of b here, you have s. So what should be the final answer? Already one root of 2 by pi is sitting out into b by. So b, in the place of b you have s. So s by a squared plus b squared. What is going to be a squared? See, a is 5. So a squared will be 25 plus b squared. B squared is s squared. So look at this answer. You are having a function of s. So always Fourier sine transforms, final answer will be in terms of s. That is the output. So these two we have got now. This is the input function, which is e power minus 5x, for which when we take Fourier sine transform, this is the output function, that is root of 2 by pi. See, this is the answer of the Fourier sine transform we are taking and writing here. So these two functions we have to substitute now in Parseval's identity. So let us write the Parseval's identity once again here. So here in this Parseval's identity, left side is f of s square. So substitute. This is going to be the f of s. Let us square that. So when you are squaring this, you have 2 by pi s by s square plus 25 the whole square ds. Right side you have f of x square. So f of x is e power minus 5x. That you have to square. It's going to be e power minus 10x. So here we have shown that e power minus 5x, when we square, you have e power minus 5x into e power minus 5x. That is actually e power minus 10x. And when you look at this integral, integral e power minus 10x is very simple to evaluate. So let us evaluate and find that answer. E power minus 10x, when you integrate, you have e power minus 10x divided by minus 10 from 0 to infinity. Now apply the limit. The upper limit, in the place of x you have to put infinity, minus lower limit, in the place of x you have to put 0. So e power 0. Now again, the values of exponentials. E power minus infinity value is 0. So this is going to be 0. E power 0 is going to be 1. So this will be 1 by 10. So the value of this right side integral simply we have evaluated as 1 by 10. Now look at the left side. Here you have a 2 by pi constant which we can take out, 0 to infinity. S square by s square plus 25 the whole square ds. This is what we have in left side. This is equal to the right side answer. We have got 1 by 10. So this is how we have reached. Now look at the question. See, look at the question. Here you have same term, but of course in terms of t. So just we need to change the variable name alone. Changing the variable name s to t. Here you have 0 to infinity t square divided by t square plus 25 whole square dt. See, just s terms have become t, equal to 1 by 10 into, take this 2 by pi to the right side as pi by 2. The final answer is going to be pi by 20. See, this is the integration which we need. The final answer is pi by 20. So this is how we have to evaluate integrations like this using Parseval's identity. I think you would have learnt now. So using the concepts, whatever you have learnt, try to do these problems. Thank you.